Welcome, I'm Dr. Angela Siegel, and today we're going to cover nested loops. If you're following along in the book Big Java Late Objects, this can be found in section 4.8. So we've seen other data structures that were nested. We've learned about the nested if statements that allow us to make more complex decisions. Complex problems sometimes require a nested loop, one loop nested inside of another loop. The nested loop will be indented inside the code block of the first loop, just as we did with nested if statements. A good example of using nested loops is when you're processing cells in a table. So if you want to go through the rows and columns of a table, this is a great example of using a nested loop. The loop through the columns would be nested inside the loop through the rows. So the outer loop would iterate over all of the rows of the table. The inner loop would process the columns of the current row. Here is an example problem statement for which we might use nested loops. And this is if we wanted to print a table with 4 columns and 10 rows containing the powers of x. So the first column upon each row would hold different values of x from 1 to 10. And as we go to the right across columns, we would see that we'd hold x squared, x cubed, x to the 4th. So how would you print a table with these rows and columns? We'd have to apply nested loops. To print the table body, we'd have to decide how many rows are in the table. In this case, we have 10 rows. So then we'd have to decide how many columns are in the table. We've already specified that we want to hold x to the first power, x squared, x cubed, and x to the 4th, so we have 4 columns. Now we need to apply a loop to print the rows. We loop through rows first because of the way that printing works, so the way that we output data to the screen. In each row, we would have to have a nested loop to loop through and print the columns for that current row. In our example, we see that there are 10 rows in the table and 4 columns in the table. So the outer loop would look something like this. We're going to allow x to run from 1 up to 10. So x can be any integer value less than 11. And the inner loop, these are the powers that we're raising x to, can run from n equals 1 up to n equals 4. So any integer n less than 5. So what does this look like, a flowchart of a nested loop? In fact, it is a loop within a loop, as we've described it. The red loop here, nested inside another loop. So the name makes a lot of sense when we look back to the flowchart. We have one loop inside the other. And so our outer loop in green is shown here. We enter with x equal to 1. And the condition that we're checking is that x is less than or equal to 10. In the previous example, that was x less than 11. The same works with x less than or equal to 10. And if that's true, we enter the inner loop. We set n equal to 1, and we carry on within that inner loop as long as n is less than or equal to 4. We're going to print x to the n, increase n by 1, and stay within the loop as long as n is less than or equal to 4. Then we are going to print a new line, increase x by 1, and return to that outer loop. So if we want to embody this in a Java file, it might look something like this. Here we have a public class powers, and we have some maximum x, some maximum n, and we're going to print the powers of x for x from 1 to x max, whatever that's set to. In this case, we've set it to 10, but we might want to leave some space for growth if we want to see the powers of 1 to 12, or if we want to increase the number of powers that we wish to explore. Maybe as we learn those powers, then we can have a variable x n max that decides what is the greatest power that we're going to output. This first loop outputs the headers for our file, and the part that I want to focus in on is the bottom nested loop. And this is going to run from x equals 1 to x less than or equal to x max. And the inner loop is going to run from n equals 1 to n less than or equal to n max. So those variables set at the top. And then we're going to output. And you can see here that we're using a formatted print statement. And if you haven't seen this before, what this does is it says the F tells you that this is where I'm going to put a floating point number, and it's going to expect that later. And it says it's going to allocate 6 spaces. And I'm doing this because we're printing a table. And so because I want to print the table in a way that looks clean, then I'm going to say each column is going to get exactly 6 spaces. And I actually know that I'm giving it integer values. So I don't want any decimal place, but math.pow returns a float. And so in this case, I just want to be ready for that, but not show any decimal places. So what this results in is we've created an outer loop that's running from x equals 1 to 10, and an inner loop letting n run from 1 to 4. And we go through on each line, we're going to output the power of x to the n, the power of x, which is x to the n. And then when we finish that line, we're going to print a new line, drop down, and start all over again. So we'll print x to the first, x squared, x cubed, x to the fourth, and then drop to the new line. And what that looks like if you run that file is the following. So you're going to create a table, and each column has 6 spaces, and you're going to just output the powers of x as we see here. So that's it for now. Until next time.
I've got a problem to solve, and I don't know where to start.
I bet I can help you. Next time, we'll cover problem solving, especially those problems that contain loops.
No, not like that. My zipper is stuck on my jacket.
Oh, I bet we can fix that as well. But just a moment. See you next time.
Thanks for watching. Okay, now can you actually fix my sweater?
Yeah, probably can. Maybe.